All right, so in this video, we're going to talk about the combined gas law. Now, when the amount of substance remains constant, so you're not changing the amount of substance anywhere, we could essentially combine all the three gas laws that we talked about in the previous videos. So Boyle's law, Charles' law, Gay-Lussac's law. When you combine them, you'll get what we call the combined gas law here. So P1 times V1 over T1 is equal to P2 times V2 divided by T2. All right. And so let's just kind of just do an example of using the combined gas law. All right, so here's the example. A 6.3 liter sample of helium gas is stored at 25 degrees Celsius at 1 atm pressure. It's transferred to a 2.0 liter tank and maintained at a pressure of 2.8 atm. What temperature is needed to maintain this pressure? All right, so let's go ahead and kind of highlight what we have here. So we got 6.3 liter sample of helium gas, and it's stored at 25 degrees Celsius at 1.0 atm pressure. All right, and it's transferred to a 2.0 liter tank and maintained at a pressure that is 2.8 atm. All right, so these are all the different numbers that we have. And then finally and lastly, it's asking us to figure out at what temperature does it need to be maintained. So it's temperature that I'm looking for. Okay, so I'm looking for essentially T2 here. All right, so what I'm going to do, and typically this is the way I tend to do things, I like to rearrange the equation, solve for a T2 right then and there, and then go ahead and plug in the numbers. All right, so when we do this, at least with this type, you will end up cross multiplying. So you have P1 V1 times T2 equals P2 V2 times T1. All right, since I want T2 by itself, I'm going to divide out P1 V1 to the other side. All right, and so that way at the end, there you go, at the end, T2 is equal to P2 V2 T1 divided by P1 V1. All right, so now let's just go ahead and plug in our numbers, right? The plug in numbers that we have. But first thing first, before we do that, we need to change the temperature, the T1 temperature. So T1 is 25 degrees Celsius. If we add 273, we get 298 Kelvin. All right, so we got to make sure that we have that. All right, and so now let's go ahead and plug in our numbers. So P2 is the 2.8, so 2.8 atm. V2 volume 2, it goes into a 2 liter tank, 2.0 liter. All right. T1, the original temperature, which is 298 Kelvin. All right. P1, the first pressure is 1 atm times the volume. The first volume is 6.3. Okay, and so when you put this in the calculator accordingly, we get that the temperature that that needs to be maintained is going to be about 260 Kelvin. And so that's the answer for this case. So that's how you basically use the combined gas law. And so whatever you're looking for, just rearrange your equation to solve for that particular variable and then put your numbers in.